And welcome to today's video. Today we're going to be doing 339 nested list weight sum. So you're given a nested list of integers, nested list, where each element is either an integer or a list whose elements may also be integers or other lists. And the depth of an integer is the number of lists that it is inside of. So for example, we have this list over here, and each integer's value is set to its depth. That kind of makes sense. At the very top layer, we have 2, which is equal to 1, and because there's a nested list inside that, we get 2 and 2. Okay, that makes sense. Same thing with this one, 1, 2, and 3, because it's 3 layers in for 6, 1 layer in for 1, and so on and so forth. And we just want to multiply that as our final value, like add all of the multiplied values, multiply by its depth. Okay, this makes sense. And the range of the integers in the nested list is within negative 100 and 100, and the maximum depth of any integer is less than or equal to 80. Okay, so I guess what I'm thinking about doing here is we do like some sort of a BFS. So as we go along, we'll keep track of what the depth is from the root, and then whenever we go down one level, well, we'll just like keep that as part of the track. We'll keep track of that as we go along. So yeah, just like a BFS where we're gonna go and keep track of the level that you're on, and then at the very end you're gonna be multiplying that to the final result as we go about it. So I think this one's relatively straightforward. I'm going to go ahead and begin coding this up now because it's just a standard BFS with a level. So we'll start a BFS with a queue. So have a deck, and then we'll have a deck, and then we'll initialize the deck with the first element in the nested list, where I guess like the first thing from the list. We have a series of methods here where we have the nested list. Where the nested list grabs a list that this nested integer holds. Okay, that makes sense. And then if it holds a nested list. So maybe at first what we're going to want to do is we're going to want to do nested list dot get list. I want to see if it it should always there will always be one element in the nested list, so we don't have to check for like a null value. Next thing that we want to do is for while the queue exists, you want to create the current level. So cur is equal to the cur is equal to q dot pop left. And actually we want to do this for while for I in range length of q. We want to do it for the given level. We want to be able to pop, so q cur is equal to cur dot pop left. So this will pop the first element, or the first element from this list over here. So from here, what we want to do is, let's see, nested list. We want to pop, and for every single thing, we want to check to see if it is a integer. So if cur dot is integer, then we want to add this to the result. So we'll have like a result variable here, 0, and then we'll return res at the very end. And if it's an integer, we want to do res plus equal cur, and then we want to have a depth variable. So we want to have cur and cur and then the current depth. And if it's currently an integer, we want to do res dot res plus equals the cur times the depth. And I just realized here I'm not quite sure if we are allowed to just get the list and then have that as part of our deck. Let's actually initialize the deck first with the first elements in here. So we actually want to create a new list of nested integers for everything for here, because we want to keep track of the depth as well, and we want the depth of this one to be 0. So we want to have this be a tuple of the current value, which is v, and then the tuple of 0 for v in nested list dot get list. So this way we're initializing everything in the initial list with a 0 denoting the depth of it. So that's what's going to happen. If it's an integer, then it's going to multiply it with the current times the depth, or actually, the depth needs to be at 1 because it's a 1 originally. Need to change this to 1. So what I'm saying is like if it's an integer, we multiply the cur and the depth with the result here, and then what's going to happen next is that you're going to go ahead and check to see if it's not an integer, right? If it's not an integer, then you want to add it to the deck, except we want to add it with the depth added by 1. So we want to do res plus equals, or like, sorry, we want to do q dot appends the nested list dot get list, and then we want to do this. We want to append the nested list the same thing as this. So we want to do v and then depth plus 1 for v in nested list dot get list. Well, in this case, we actually want to do cur dot get list because we want that to be our final value. Yeah, I don't see any other useful values which you could do for this. And at the very end, we can go ahead and return this as our final result, because yeah, like if oh, we also want to check to see if cur is actually existing as an element. So we want to do if cur. Then if it's an integer, otherwise we just append this to the list. Yeah. Okay, so just to walk through how this will work and to verify that it works just by doing a dry run, we're going to have this nested list as an example. What's going to happen is you're going to start off at this one, right? And it's going to add everything at the current top level over here. These are all nested integer objects, which are denoted here. So what's going to happen is it's going to loop through, and if it exists, well, it does. If the current isn't integer, this is not an integer, then we're going to want to append this to the queue. So we're going to have a queue that's equal to like something like this, and we're going to append the 1 1 here. And we're going to append the 1 1 with the current depth, which is 1 plus 1. So it's going to be equal to this. So this is the depth, this is the current list, and it's going to move on. Now, next one, we hit 2. What's 2 equal to? Well, 2 is just going to be like, it's an integer, so we multiply that with the result. So the result becomes 2 because it's just 2 times 1. And then we have 1 and 1 here. We encounter this again. So this becomes 1, 1, and then, sorry, this becomes 1, 1, and then 2 again. So these are both added to the queue. Now, that's finished the first iteration. We're going to run through this again, and we're going to see this again. So we check to see this, and we pop this one from the stack. So, well, is this an integer? Well, is the value the integer, the current value the integer? No, it's not. It's a list. So it's going to go, yeah, it's going to go, it should go deeper down. This should be 2. So is the current value an integer? No. So then it's going to append the values forward. It's going to append the values here. Oh, no, sorry. My example is a little bit off. It's not going to append it like this. It's going to append it, Oh, we actually don't want to append it like this, where we append it as its own list with full of tuples. We actually want to append it for every single value for v in cur dot get list. We want to append this one. We want to append the individual elements. So we want to do res dot appends. Yeah, we want to do, we want to do cur or q dot appends, and then we do the v and then the cur plus 1 from here. So it's going to do that for every single element instead. So instead of a list, it's going to be equal to something like this, like 1 and then 2 and then 1 and then 2, 1, 2, 1, 2. And from this one, then it's going to check to see, is it an integer? Well, no, it's not. And then that's what's going to happen. You're going to keep moving forward from there. So yeah, I think that should be better now. And then it's gonna pop out all of the elements from here. It's gonna pop it out. And then it's gonna add that to the result because it's a number. Same thing with this one, multiply by the depth, multiply by the depth, multiply by the depth, and that should be our final answer, which should be 10. So if we go ahead and run this now in order to verify. Oh, okay, I see. List. Oh, I forgot. The initial element here is actually just like a list of nested integers. So we actually don't need to call get list for the initial depth. And for here, oh yeah, we need to do q.pop left, not cur.pop left. One final thing here, you want to do unsupported type, operand type for nested integer. Oh, we have to do get integer and ints because we need to grab the actual value itself. So if we run this again, oh wait a minute, no. Wait, what? Sorry, wait, I'm getting kind of confused now. This is supposed to be the depth. So this is supposed to be depth plus 1. Yeah. Unsupported operand type. Get integer. Okay, there we go. Yeah, just a couple syntax errors. I really need to, I guess this is something I need to improve on for the future. I need to figure out, like I need to really read the specs here and just make sure that like I need to like parse or like grab the integer with the methods provided instead of just assuming that the cur is is like an integer from the get-go. So I guess if we run this, time accepted, yeah, it's accepted, and time complexity should be good. It should be O of n because you're iterating through for every single element in the nested weight sum, and the space complexity is going to be O of h, or I guess like yeah, like O of h average complexity, where it's going to be like the time. Actually, the worst case time complexity, this one is going to be O of n because in the worst case you're gonna have a scenario where like the array goes all the way down to the very bottom, just super deep, and then like you're gonna have to like yeah, like keep adding that to the stack. So it should be O of n space complexity as well. So yeah, okay, thank you guys for watching.